Welcome back. This is my second class on Analytical Geometry 2. Before we start for the day, we would like to recap some basics of AG2. No, I just say Analytical Geometry is AG2, so that the next chapters, the subsequent chapters, you can have a better understanding and better workability. So for that purpose, I'm just doing a recap, which you must have learned in the previous classes, maybe in +1 or somewhere else. Recall one more point before we start. We are now discussing analytical geometry. It is a subject deals with geometry without the geometry. So what you try to say is that when there is a geometric curve, it is very difficult. I told you the reason last class. It is very difficult to understand, visualize the geometry behind it. So we try to convert it mathematically with easiness and investigate the geometrical curves. Even as I told you last time, more than 3 dimensions even can be discussed using analytical geometry. So this is an attempt we are making it. So as I already said, let's do recap for next 5 to 10 minutes. I have to save my energy and time. I pointed out here all the points, about 10 points in this part, and probably we'll extend it in the subsequent classes. Let's begin with a basic assumption in analytical geometry. We are dealing with geometry and geometrical figures. We are dealing with geometry and geometrical figures. That is all at the moment we are discussing it. So let's begin with a 2-dimensional surface, like a blackboard or a paper, all that. We start with a point. What is a point? A point is a position. A point is a position drawn on the surface. A point is a position drawn on a surface. To the surprise, after some time, the position, the shape, and even the dimensions will not be carried into this. It will be assimilated over the process. We will see that later. But let's begin with a point. What is a point? A point is a position in a plane surface. I think it's very clear. So we usually draw a point with a dot, something like that. What is the locus of a point? Assume that the point is moving in some direction, in some trace path. Well, I don't use the word direction here because we don't study vectors, we only study scalars. So if a point moves with geometrical property, if a point moves with a geometrical property, it's called locus of a point. So second point is locus of a point which moves with geometrical property. Well, as I said, we are not going to encounter directions here, only the path is traced. The third point is straight line. When you take 2 points, the shortest distance between these 2 points is called a straight line. What is a straight line? A straight line is the shortest distance between any 2 points in the given surface. We are all talking about only a 2-dimensional surface at the moment. Later, when we discuss 3-dimension and other things, it is dimensionless. We can still discuss all these concepts without using even dimensions. So what is a straight line? A straight line is basically the shortest distance between 2 points. There is a hitch here. What is distance? We'll talk about the distance after a few minutes. What is the curve? Now, sometime back we told you a straight line is the shortest distance between 2 points. If it is not the shortest distance, some tracing between the 2 points is called a curve. Well, there is no formal definition of a curve can be given with a geometrical perspective, but we will give you the curve definition in analytical geometry little later. So what is a curve? The curve, a straight line bends, the straight line curves. No, it curves itself. It's called a curve. Let's now go to the word tangent and normal. You take a curve may have a bend. I told you something like this, it's go like this. Maybe I draw a small picture, this is a curve, this is a curve, this is a curve, this is a curve. So it's curving, you know, between 2 points. So point A and point B, point A and point B, point A and point B, and so on. Now, the tangent and normal are the two important nomenclatures needed both in geometry as well as in analytical geometry. What is a tangent? Suppose there is a curve and a straight line. We have defined what is a straight line. We have explained what is a curve. Suppose there is a straight line, there is a line, touches the curve only at one point. So imagine this is a curve, there is a point here, a line touches the curve only at one point. It is very difficult to draw the graph. It's very difficult to draw the graph. So what is the tangent? A tangent is a straight line. It is a line touches the curve only at one point. Let me stress this one more time, because if this is not clear, we cannot develop the next level of tangents and other configurations in geometry and analytical geometry. If a line touches the curve more than one point, it is no more a tangent. Okay, so a tangent is a line. It's basically a line which touches the curve only at one point. That's very clear by definition, because as I said, if it touches more than one point, it is no more a tangent. That's a very important point the tangent property has. What is the normal? So I talk about normal. What is the normal? A line perpendicular to the tangent is called normal. What is perpendicular? The angle between the lines is 90 degrees. I will not talk about the angle or trigonometry and all here. I assume that you know something in the lower class, you have learnt it. If the angle between two lines is 90 degrees, it's called a perpendicular line. But a normal line is a line perpendicular to the tangent. What is a tangent? A tangent is a line touches the curve one and only one point. That's a very important definition, because later to handle big surfaces and other things, tangent and normal play a very important role. So what is a tangent? A tangent is a line touches the curve only at one point. What is a normal? Normal is a line perpendicular to the tangent. So let us not deviate from that. These are the nomenclatures you're supposed to know to handle AG2. We are now discussing something like recapping AG1. Now let's revert back to a straight line, because only from straight line every other geometrical configurations will be constructed. What is a straight line? We already discussed some time back. A straight line is the shortest distance between 2 points. A straight line is the shortest distance between 2 points. Now, so far, all these nomenclatures, all these technical terms, all these words were used geometrically. Point, line, angle, they were all discussed geometrically. But unfortunately, or even fortunately, we will not talk about the geometry, we talk about the algebra behind the geometry in this particular subject. So it's a high time, it's the right time to introduce a straight line non-geometrically. This is the starting point of analytical geometry. From here, we are going to develop 2 dimensions, 3 dimensions, even multi-dimensions. I've been telling very often in my previous classes, the human mind cannot imagine more than 3 dimensions. But analytically, we can discuss multi-dimension, even infinite dimension. That's the reality. We'll talk a little more about that when you go for other sections. Let's come back to the linear equation again. What is the linear equation? In mathematical world, linear means in mathematical world, linear means of power 1. But let me not bring that mathematical part at the moment. I say an equation, linear equation, if it is of the form ax plus by plus C is equal to 0, where A, B, C are constants. Let me summarize what I tried to say in the past 5 to 10 minutes about straight line or equation, so linear equation. Every straight line, any given straight line can be represented by an equation ax plus by plus c is equal to 0, where the power of x is 1, the power of y is 1, a, b, c are usually taken to be real constants. We'll talk about the real constants, the complex constants, monic constants, all that little later. But at the moment, any equation of the form ax plus by plus c is equal to 0 represents a straight line. Let me be specific what I try to say, because from this moment onwards, without studying the geometry, we are going to study the geometry. So without drawing, without pictures, without graphs, we are going to study it. Let me summarize what I said therefore one more time a little differently, so that really the essence of linear equation, straight line are matched. Every linear equation represents a straight line. Every straight line represents a linear equation. An equation is linear if and only if it is a straight line. An equation is linear if and only if it is a straight line. So straight line and linear equations cannot be viewed differently because they represent the same. Caution, I am talking about all this at the moment only in two-dimensional cases. In three dimension, we have something else to discuss. We'll discuss later about that. So in two-dimensional geometry, in two-dimensional graphs, a straight line represents a linear equation. A linear equation represents a straight line. Let's now talk about the next two important words in straight line. These things are important because this is the foundation of the AG, the analytical geometry. So without knowing this foundation, it's difficult to understand the next configuration of geometry. Let's start with the slope and the intercept. We talked about a straight line. If a straight line makes an angle theta, with x-axis, in two-dimensional geometry we have x-axis and we have y-axis. Maybe you can draw like this is x-axis.